Okay, we're going live. Hopefully everyone can hear us loud and clear. Welcome to BrisJS, everyone. Normally through my slides up here, and I will do that in just a minute. Just letting everyone get the latest. It's on a bit of a 10-second delay, as we see with the YouTube streaming. So I kind of give it a little bit of time just to make sure that we're all there and I can see the chat. Thank you, everyone, especially to the first timers. We appreciate to have you on board. Hopefully you enjoyed tonight. There's a couple of great speakers as usual, and we'll be able to get some really cool insights from everyone. I can see the viewer count is starting to creep up, and that's good. We're okay. We're hopefully getting a stream coming through. All right. All right. Someone say hi on the stream. Let me know if you've got everything in order, and I'll kick off with some slides. Thanks, Dylan. Appreciate that. All right, let's kick off. Okie doke. Let's share some slides. All right. You'll see me slightly smaller, and that's a good thing. Thanks, everyone, for joining us tonight. I know it's been a little bit of a break between these. Thank you very much to our speakers for volunteering tonight. You made this happen, so I appreciate that. I think last time you would have seen us was the trivia night that we did with the Sneak guys. That was really good fun. I think next time when we do it, maybe slightly less questions, keep it a bit more punchy, but we did have a long, good night of lots of fun. And I'm glad to see that we got some folks winning prizes there, answering all the random esoteric JS questions. And it was very competitive there. We had a couple of folks that were really neck and neck for a little while there. So yeah, I think we did pretty good. Cool. All right. So I'm assuming I'm coming through correctly because I'm not getting the feedback from YouTube as I usually do. So you do see stuff advancing. So I'm going to proceed unless somebody says what's going on. But thank you again for joining us. I'll go through my usual preamble. One of the important points that I'd like to point out is we like to be able to get this as interactive as possible and still maintain some organized chaos. We'd like to funnel everyone's questions and any feedback and things like that into Slido, which is a cool online service. You can go and put Q&A in there, get some live feedback to questions and things. You can upvote other people's questions in there as well. It's pretty handy. You can find tonight's one at Slido 222, or you can scan that QR code. I will share the link in the YouTube chat too, so you can just click and get there. If, for example, that's not convenient to you and you can't do that on a mobile device, you don't want to switch back and forth, don't worry. If you do want to still ask questions and leave that in the YouTube in the YouTube chat, if that's more convenient to you, feel free. I'll funnel your questions over to Slido, and that way I've got one place to find them. At the end of each of the presenters' sessions, we're going to go through and then ask them those questions, and then you'll get all your answers. Hopefully that's very clear for everyone. Yeah, you can hopefully find the way to submit Q&A there. Very important to us is the acknowledgement of countries while we're all distributed. I think it's good to keep doing these things and relate them to where you are at this time. So I'd like to begin acknowledging the traditional owners of the site which we broadcast on from today, which is the Yugara and Bundjalung people. And I'd also like to pay my respect to elders past, present, and emerging. And the next slide contains a little bit of a reminder. You can help me understand a bit more of the stats around exactly who's joining and getting the information through our Meetup page. So if you are keen to check out our live stream or our physical events, which are hopefully kicking off as soon as we can make sure we've got enough speakers for those, we can track exactly what we need in terms of resources. And for the physical events, of course, it made a lot more sense where we had a dependency on buying enough pizza and putting enough chairs out and things like that. So these are still fairly important to us. It also helps me do an email out to folks who opt in to organize messages, and then you'll get the announcements by email from me as well when we have the lineup finalized and the Meetup page uploaded. You'll also see the messages on Twitter, which I'll talk about in a minute. Of course, code of conduct extends to online spaces. It is a harassment-free experience for everyone. So please do check out our anti-harassment policy at brisjs.org/conduct. #conduct to be precise. You can navigate from there from the links at the top, and yeah, just make sure that that all makes sense to you when you're interacting in BrisJS online spaces. This one I can't reiterate enough. You can see that there's been a little bit of a gap in the amount of months we've been able to do our live streams. And like I mentioned, if we want to try and get to face-to-face events as well, we're going to need to build up a speaker list. So please submit some talks. If you've seen something cool or you've been able to work on a little project, whether or not it's for your day job or for your hobbies, please do reach out. You can easily turn that into a talk. We're happy to support you to do so as well. If you're a seasoned speaker, we'd love to hear you as well. You know, we'd love to be able to get you on BrisJS and help educate everyone and share some of that knowledge around everything JS, everything web in general. You know, don't feel that, you know, if it's not specifically about JS or language features, you can't give a talk. We have a broad range of different topics that we'd like to present, and that way it keeps things interesting to all levels of skill, all levels of experience. We have some very advanced topics or some very new topics, very early basic topics as well, just to make sure that we can get something for everyone. And we like to balance those in and schedule them. And we like to schedule them through our GitHub issues page. So hopefully a lot of you are familiar with GitHub. There's a sort of a ticketing section of there, and we like to leverage that by tagging these tickets as submitted talks, and that way we organize them based on the length as well as when they can actually occur based on availability of our speakers and whether or not we're booked solid or not. So you'll see them tagged. This is probably a good place where you can have a look and see what's upcoming before we make the formal announcements as well, due to the labeling, and you'll see everything in there. There's also a couple of different socials. You'll see that we do have a Facebook presence, but it's pretty tumbleweeds at the moment. I'll try and pick that up a little bit. You'll see the most active is obviously Twitter, where I like to put out some different questions and calls for speakers. And you are on YouTube, so this is where we've been posting all our live streams. There's some past talks in there as well, and that should hopefully give you hours of watching on record. There's also brisjs.org, a little page to kind of tie everything together and a little bit of information about where we are and what we do. There's been some changes to the Meetup API, so the little box to the right there doesn't work at the moment, so there's going to be a repair there. Your pull requests are also welcome. So there's another little feature in there. If you are in need of a job or keen to advertise one, there's a job board as well. This is actually run through GitHub as well. So if you make a GitHub post in our issues, you will also be able to then share the kinds of opportunities that you've got inside your company. If you want to get a new colleague, this is the place to do it. We will mark it as a jobs and employment issue on there, and it'll automatically appear on brisjs.org. There's obviously some sponsorship going on here. Previously, we also were getting sponsored pizza and drinks and things like that for our in-person events. But obviously now we still need Zoom Pro. So the place that I work, PCCW Global and Console Connect, is keen to keep supporting us with the Zoom Pro subscriptions. So thank you very much. Small but meaningful thing that we really need to be able to keep going through the pandemic times where we're all kind of at home. Yeah, there's also, of course, a bit of a shout out there. We're keen to recruit a whole bunch of folks. We're looking for web devs, JS engineers, senior or mid. If you're anywhere across the stack, I'd love to hear from you. So you'd be working with me on my team. There's also a whole bunch of different engineering positions as well as systems positions that we're recruiting all across the board. So please feel free to reach out. We've even got product management opportunities and things like that as well. Yeah, get in touch with me directly and I'm happy to send you to the right people. Without too much further delay, let's have a quick look. You've obviously seen some of the titles in on the socials and the Meetup page. We've got two presentations tonight. We've got feedback and the REPL from James, who will be taking you through some of his content tonight. We're also going to be hearing from carryover champ Ashley, who's going to be taking us through creating a multi-package monorepo with Pnpm. That's a tough one to say if you want to say it quickly. So I didn't. Then we'll be closing and gathering any feedback through our online polls as well, answering questions in between as well. I will stop that share and jump over here. Okay, so yeah, I'd like to just jump to and introduce our first speaker, who will be James. James, are you with us?
I think so.
Hello. Yes, you are. Welcome to BrisJS, and thank you very much for agreeing to have a chat to our audience tonight.
Thanks for having me.
It's a great pleasure. You can take it right away, and I'll step back a little bit.
All right. Hello, everyone. I'm from New South Wales, Wabakal country. Shout out to a Wabakal mob. They've been looking after this area for thousands of years. I work with my family. We've got a little business. We make mapping apps for horse riders. My dad's the sysadmin, my sister's the designer. I'm the programmer and my mum's the boss. I'm just going to share my screen here. How are we doing? All right, hopefully you can all see that. So this talk is about the feedback loops that we experience as programmers. One sec. Well, I've gotten rid of my video of myself. Oh, well, I know what I look like. Ooh. All right. So I reckon this is a pretty typical feedback loop for a web developer today. You change some code, save your file, rebuild your application or the part you're working on, reload the page, have a poke around, have a test, see if what you did worked. If it didn't work, try to find out why, debug it a bit, and that will usually lead you back to changing more code. Now, when you start a project, you know, these waiting steps over on the right, like the building and the reloading and any integration tests or unit tests you have, they all run really fast, right? And you get this lovely, like snappy, responsive feeling, like your development environment's like really working with you. But as the project grows, these waiting steps take longer and longer and things can get pretty bad. It can get to the point where you're actually spending more time waiting than doing. So why is that a problem? Like, isn't it nice to like have lots of little breaks and, you know, relax your mind and stuff while you work? Well, I don't think so. I think feedback should be fast for three reasons. The first reason is that programmers are creative people. Like artists, we respond really badly to tedium, like a slow build step or a slow testing step breaks our concentration and takes us out of the zone. Another reason is that it can be really difficult to predict the consequences of changing a bit of code. And that's why it's safe to make changes in small increments so we can match up cause with effect. A slow feedback loop encourages us to make lots of changes at once. And what that does is make it harder to find our mistakes because you don't really know where to look anymore. You've changed a whole bunch of things. And that leads to a lot more debugging, which is no fun. The last reason is that we want to finish our day with a sense of accomplishment. And it's really hard to get that when you feel like you spent the whole day waiting around. Now, I think I've got a pretty neat solution to this. But firstly, I'd like to impress upon you the importance of fast feedback. And I'm going to do that by taking you through a really bad feedback loop. So before the microcomputer revolution of the 80s, computers were slow, millions of times slower than today. They could only really do one thing at a time. They were big, often taking up like the whole floor of an office, and they were astronomically expensive. And because they were so expensive, the organizations that ran these computers, they might own them or lease them or whatever, they couldn't afford to let these computers sit idle. So they would run them at like full utilization 24/7, kind of like how we'd run like a Bitcoin miner today, right? And the way that they achieved this high utilization is that they would take a whole bunch of programs, they maybe take like 10 programs, they'd stitch them all together, they'd feed them into the computer would churn away, it would work on the first program, crunch some data, and then spit out its output, and it would move straight onto the second program. So there'd be no sort of handling in between these programs, right? And that would burn through full utilization, and that could take hours, could even take days. And the problem with this model, it was very efficient, very, very good use of the machines. But if you were a programmer that was writing batch programs at the time, you had to compete with these batch jobs, right? And if you wanted to test out your program to debug it, sometimes you had to wait hours or days to find out whether your program worked or not. And that sucked. This is a punch card. And this is how programs were communicated to computers. This is how you got your program into the computer to run. I've got one right here. It's just a thin little bit of cardboard. And you can think of a punch card like a thumb drive that only holds a single line of code, right? Very primitive. And a punch card is divided into columns. Now, if you look closely at the punch card on my slides, you'll see that each column is numbered and it goes from 1 to 80. Incidentally, that is the origin of our 80 column line limit. And each column on a punch card consists of a character printed up the top, and beneath the character, that character is encoded as punched holes. So right over on the left there, you see the P. Underneath there's 2 punched holes. So they correspond to the letter P. So it's only printed up the top for humans to read. The holes are what the computer reads, right? Now, as a programmer at this time, you didn't write your program straight onto punch cards. You wrote them on pencil and paper on a sort of grid, a bit of grid paper. And when you thought you had it right, when you thought you had no bugs in it, when you thought it was perfect, you'd queue up at the key punch machine. And a key punch is an electric typewriter that instead of printing onto paper, it prints onto punch cards. And you would stand there and you would type in your entire program. If you made a mistake, you had to throw away the punch card, and you type out your entire program, or maybe just the lines you'd changed since last time. And you'd end up with a great big stack of punch cards. You can see one in this photo just to the right of the keyboard there. And you'd carry this stack of punch cards to the operations counter. And that was where the computers lived, but you weren't allowed to touch the computers. You just hand your stack over to the operations team, and they would schedule your program for execution. They'd give you a turnaround time, which could be, it could be quick, you could be lucky, but usually you're looking at hours or days. And then you would wait. And you'd, I guess, relax, have a sword fight. Now, we don't we obviously don't work like that anymore. We don't do batch processing, or at least we don't. I think some people, I think maybe still do. So what changed? Well, very early on, there was a synergy forming between computing and telegraphy. And telegraphy is the technology behind the long distance transmission of text messages by electronic means, right? So you need that last bit to rule out carrier pigeons. Now, the way telegraphy worked is you would walk into the telegraph office and you would pay some money for them to send a short text message for you. That message would be handed to an operator sitting at a machine like this. This is a teleprinter. It is what it looks like. It's an electric typewriter hooked up to a phone, right? And the operator would dial up another operator somewhere else in the country or the world. And when they were connected, they would type out your message on the keyboard, and the message would be printed out at the other end for the other operator, who would slice it off and it would get delivered to the recipient, right? Now, these were used as early as 1887 for human-to-human communication. But in 1955, someone had the bright idea to hook one of these things up to a computer. And that's when we got the first command line interface, right? So before 1955, there was no computer that had any kind of keyboard. Now, one man who saw the potential in this teleprinter computer command line interface was John McCarthy. Now, he realized that batch processing really sucked for programmers, and he had this to say in 1959. Suppose that the programmer has a keyboard at the computer. So we're talking about real visionary here. Imagine having to say that, right? Then they can try their program, interrogate individual pieces of data or code to find an error, make a change, and try again. So he's talking about interactive programming, right? Which is basically programming with a really good feedback loop. And the only roadblock, the only obstruction to making this a reality in 1959 is that basically no one could afford to use computers like this. Because computers, if you remember, can only really do one thing. And if that one thing is being used for interactive computing, it will be sitting idle way too much. No one can afford that, right? So when you program, right, most of the time you're thinking, you might spend a bunch of time typing. You're spending very little time actually running your program, right? So you don't get a very high utilization, and that's why this wasn't viable at the time. Here we have the Wang 3300, the mighty Wang 3300. John McCarthy's brainwave, right, was that if you got enough people using one computer interactively, all that time that you spent thinking and typing would cancel out with someone else running their program, and you'd be able to get your computer running at a high rate of utilization. And that was called time sharing. And his team actually developed the first time sharing system. It's not this, in 1961. It's not this photo. It was probably a much bigger, uglier system. And it was a great big hit in universities where people needed to, focus on their programs. And it also became the basis of the internet. So when you're on a website or something, you're talking to a server that's talking to a lot of other people at the same time. That's time sharing. If you've heard of AWS Lambda functions, that's also time sharing. It's all the same idea that we have a machine that can do lots of things at once. Now, John McCarthy's other great invention was Lisp, which is a programming language. Now, John McCarthy was one of the pioneers of artificial intelligence. He actually coined the term, and he started the first 3 artificial intelligence labs. And he realized that if they were going to write really smart programs, they needed a smarter language than Fortran and COBOL, right? Like these were extremely clunky languages. Fortran was designed for scientific computing, like crunching numbers. COBOL was designed for producing business reports. They just weren't doing what he needed them to do, right? So we came up with Lisp, which was a much higher level language, a much smarter language. And Lisp was the first high level language to have conditionals, like if else. You don't even want to know what they were doing before they had if else. Recursion, so functions could call themselves by name. First class functions, so if a function could receive other functions as its arguments. Garbage collection, which was a biggie, because if you're making artificial intelligence, you need to model sort of thought, right? And the only way you can model thought is by having data structures that can grow and shrink in real time. And it's too painful to do if you have to manage your own memory. So garbage collection was this great feature where the programmer just didn't have to worry about that at all. They could just focus on their program, on what they were modeling. And Lisp also had the REPL. I'll just pause there. I'm gonna talk more about the REPL, but try and think of a language which has all of these features that we use every day. If you thought JavaScript, you'd be correct. Now, the REPL is not actually a language feature as such. The REPL is a program that you can use to interrogate individual pieces of data and code. This is the source code of the REPL program in Lisp. Now, if you're not familiar with Lisp, don't worry, it's a lot like JavaScript. Each matching pair of parentheses here is a function call. So we'd read this from right to left. First thing that happens is the read function is called with no arguments. And that writes a prompt to the teleprinter and waits for the user to type in some source code. When they press enter, read returns that source code, which is passed to eval. Now, eval evaluates that source code to a value and returns that and passes it to print. Now, print prints out that value as text back to the teleprinter. And when it returns, loop sends us back to read, and it all starts over and over again. Now, the best way to understand, okay. Read, eval, print, loop, REPL. Now, the best way to understand the REPL is to see it in action. And us JavaScripters, we're really blessed. We have such good access to JavaScript REPLs, it's not funny. Basically, every computer in the world has several JavaScript REPLs installed. And that's because there's a REPL in basically every browser. And you can get to the REPL by right-clicking on the page, pressing inspect, and you want the console tab. Now, the console tab is where all of your logs and errors and stuff get spewed out as your application runs. But down the bottom, you should see a prompt, and that's an invitation for you to type in your source code and have it evaluated. So let's evaluate something real simple. We can also run functions. We'll get a random number. We can run functions that have side effects. And notice we get two things back here. The first thing that happens is the text hello world being printed to the log. And the second thing is the return value of the console.log function. We can also access the DOM. So I'm going to use the DOM to give this slide a bit of historical realism. There we go. Lowercase only came in the 60s. And we can also schedule tasks to be run at a later time. So I'm going to ask that in 5 seconds, a bit of text be printed to the log. And set timeout returns a timer ID, which we can use to cancel that task. And then it prints the text. Now, the REPL is a really great learning tool. If you're not sure what a particular bit of code does, you can always just ask the REPL. And the REPL is like this oracle. It's never wrong. Whatever you ask the REPL, it will tell you exactly what JavaScript is really going to do. And that's really important. It's really important to have a sidekick like that when you're working with JavaScript, because JavaScript has a lot of bad parts. I mean, it was developed in a rush. Its sort of deep problems have never really been fixed. And there's a whole large portion of the language that you really just shouldn't use. And the REPL lets you sort of experiment with these parts of the language and decide for yourself whether you want to go and put them in your programs, rather than just going and putting them in your programs and then discovering that they cause all of these horrible bugs. For example, JavaScript actually has a Y2K bug, which is hard to believe considering JavaScript was designed and released in 1995. But here it is. I'm going to ask what the current year is. And I get a completely nonsensical answer. Now, what this method should do is return a 2-digit year. But what it does in reality is return the number of years since the year 1900. Now, if that is not weird enough that someone wrote that in 1995, it's actually not JavaScript's fault. Well, it sort of is, but there's also a get year method in Java, and it does exactly the same thing. You can look up the Java docs. JavaScript just copied the date object exactly, including this insane mistake, which is just so crazy because Java was also designed and released in 1995. I don't know how they did this. Anyway, I noticed that everything I've typed in so far has been pretty low level, right? And that's because all I've got to work with are features of the language, like numbers and strings and math.random, features of the runtime, like the DOM, and anything I've already typed in. So, you can declare functions in the prompt and then you can call them later. Now that might have been an all right way of developing applications in the 60s, but it's not how we work today. Like we don't develop applications, piece by piece on a teleprinter. We structure our application as modules, and the modules live in files that we edit with our graphical text editors or our IDEs, right? Now, it's not immediately clear how we're supposed to play around with our own code in the REPL. Like, how can we import one of our own modules and test it out? How can we import a library that we're thinking of using and test it out? It's not obvious. Like, one thing you could think of doing is copying the code from your text editor into the prompt. And that will sometimes work, but it won't work if your module contains an import statement, because import statements are not supported in prompt-based REPLs. Now, it turns out, okay, so this is a dilemma. We've got this brilliant tool, the REPL, that gives us really fast feedback, but it's kind of completely hamstrung because we can only use it on like the lowest strata of our code, like the lowest level code that doesn't import any other modules. It turns out this has been solved, and it was solved almost 50 years ago by Lisp programmers. But as far as I'm aware, it hasn't been solved with JavaScript until now. So I'd like to show you what my solution looks like, which is a JavaScript solution. So this is my text editor. It's called Sublime Text. There's nothing special about it. except that I've written a plugin for it so that when I press certain keyboard shortcuts, it sends source code to a REPL running in the background and sends the output back to this pane on the right here. And we can do all the old favorites from the prompt REPL. We can even blow up. And we are still hooked up to a web page, so we can modify the DOM too. There we go. And we can also do something that we couldn't do before, and that is import modules. I'm going to import Vue, which is a JavaScript library for making user interfaces, very similar to React. I'm sure you've heard of React. Just run that. All right. Now we'll see what we got. The version number of Vue we got is 3.2.37, which looks about right. So now we've fixed that limitation where we couldn't import modules. So we can really get some work done. And I'm going to demonstrate that by making a UI component. The first thing we do when we make a module is write a specification, right? In Vue, a prop is like a parameter for your component. You'll see what I mean. I'll just let my linter know that I'm working in the browser. All right, so once we've got a specification, it's good practice to write a test. Now I've come to believe that automated testing of user interfaces is not worth the trouble. And what I've been doing instead, which I'm quite happy with, is writing a demo instead. So for each component I make, I write a little demo, and I'll do that now. We pass the create app function R component, and we'll give it some props. And we'll mount it to the document. Now, it is nice to run a test before you've actually implemented the module, so we'll do that. It blows up because we haven't defined our component. So now we implement. Now a component is an object which takes a props object. Just say both of the props are supposed to be strings. And it takes a setup function. And the setup function is called when the component is first instantiated. And this is where we do any setup work, if we had any, but we don't. So we're going to straight away return our render function. Now, the render function is called whenever the props change, and it returns basically instructions for which DOM elements to render. So we're going to return something super simple. We're just going to make a button element which contains a pleasantry prop. Let's see what happens when we run that. There we go. We've got a button, but it doesn't do anything, which is very unsatisfying. So what we'll do is we'll add handler. And when someone clicks the button, we will alert them with our reply. We'll just add that handler to our element. Let's see what happens. There we go. Okay, so we've got this working module. I'm going to comment out the demo. That's there for anyone that wants to come back and maintain the module in the future. And we'll export our component. And what we end up with here is something that I like to call a whole module. It's whole because it contains specification, which tells you what the hell this module is about. It contains a test in the form of a demo, and it contains the implementation. And the combination of these three things makes a module like this very portable. It can be put into other projects really easily because it's sort of self-contained and self-sufficient. It's really maintainable because anyone that comes along doesn't have to hunt around for where the tests are and for what the thing does. And it gives you really nice feedback, right? Because instead of running a whole application to test this module, we're just running the module. We've turned the module into its own little application. And actually, what we've done is turned our feedback loop into this. Now, this is different from that feedback loop we saw before because it's missing the build step and the reload step. The save file step has been replaced with evaluate code. The test step might run faster because you might be running tests on less code, and the debug step might be faster because you've got less code running, so there's less places that your bugs are going to be hiding. So the tool you've just seen in action is called Replete. And I wrote Replete because I'd seen people using REPLs like this, but only in other languages. I'd never seen someone do it in JavaScript. And I wanted to know if it was possible. And I also wanted to know what it felt like. And I can report back, it feels awesome. I use it every day. I use it for front-end code, back-end code I put into production, wild experiments I have, and you can use it too. I've put the source code online. It's totally free and stuff. To install it, you have to get a plugin for your text editor. I've written plugins for these 4 editors, but the plugins do almost nothing, right? They just listen for keyboard events and send a JSON message to the REPL, right? And the VS Code one, for example, is like 50 lines of JavaScript. It's really easy to make these plugins. So if you wanted to use Replete, but you didn't see your text editor here, don't worry about it. You can find your plugins. They're linked from the README in the repository that's linked to just there. And once you've got it installed, you can start evaluating code from your modules in any browser. So I was using Chrome, but you could use Safari or Firefox. You can even use browsers running on your phone, which is handy. You can run code in Node, and you can run code in Dino, which is the spiritual successor to Node. These days, it's no longer computer time that is the precious resource in a software project. It's the programmer time. And I really hate waiting for build steps and test steps. I get this sort of restless, trapped feeling because I don't want to move my attention onto anything else, but I can't proceed until I get that feedback. Fortunately, computers are really fast now. If we put our minds to it, we can devise feedback loops that have no noticeable delay, feel really snappy, like that brand new project. And I think that's what John McCarthy was talking about 60 years ago. And we can have that now, right? Thanks, everyone. That's been my talk. I really love talking about this stuff. I'd love to, if anyone out there wants to use Replete, I'd love to know how you went, if it worked, if it didn't work. I really want to know if it didn't work, because I want this to be a thing that people use. I think we have question time now. I didn't start my stopwatch, so I don't know how much time we have.
You're all good. You're all good. We can definitely do question time. We've got quite a number of things that we can get some chat on. So that's great. Thank you very much. I'll do the meetup clap. It usually is a resounding audience, and I will do that on their behalf.
Thanks,
So thank you very much for that. I will jump in to, yeah, there you go. Alison on the chat says, to give it a go. Looks awesome. Okay, so you already answered the first one as part of your presentation. What does REPL stand for? Read, evaluate, print, and loop. I've answered that one in line, so hopefully you can move forward with that one. The next question that was in there, I'm just going by chronological order. Were those timeshare teleprinters all using basic language? Were they then adapted for Lisp? I think that's more of a tech historical question.
I have no idea. I just found that photo on the internet and I thought it was like just so cute, like these little Vegemites sitting around programming on their teleprinters. Like, yeah, I mean, that must have been a later model because the computer's so small.
Mm-hmm. Yeah, it's profound how exactly, you know, how what a leap in kind of interactivity and programming that probably would have represented back in the day. And then, you know, you leapfrog to now, we've got multiple levels of abstraction that we're doing there as well. So yeah, it's very amazing how that went through. The next question in here was, do you think you find automated testing for UI less useful because you're a solo developer? It's a two-part question. How do you know what your demo is meant to do in the future? That's two questions.
Well, okay, I'll take the second question first. You should know what the demo is meant to do based on the specification. So you define what the module is supposed to do, and then your demo is for you to basically play around with and see what it does. What I like to do with the demos is feed them with random input data. So every time I reevaluate the component, I see it looking, you know, totally different, and you can sort of see it in all of its different permutations, which I found extremely helpful. You can sort of use random data to try and break your component in front of your eyes. What was the first part again?
Our first part was, do you think you find automated testing for UI less useful because you're a solo dev?
Like, I mean, I don't know, like I've been a solo dev for ages now. I found I was using automated testing for UIs. I was using a lot. I was using the WebDriver IO framework. And then Node 16 came out and the sync mode stopped working, and I lost all of my end-to-end tests for all of our applications. And it was like something I'd been sort of nurturing like for years, because, you know, they're so flaky and they take so much work to get not flaky. And then once you've got them right, you don't really want to change them. And that means that your UI is restricted from changing. You're reticent to change the UI, but really you want to change the UI a lot. Like you want to be able to respond to things your designer says like straight away. And it's just, I find that just so much easier to do with a demo.
Yep. Fair enough. Fair enough. I have one question in here, which is, what are your thoughts on Quokka.js by the Wallaby.js folks?
Oh, what was it called? Sorry?
Quokka.js.
Oh, I've seen that. That's like it's sort of, yeah, I've seen it, and that's cool. It's awesome that they're, you know, bringing that feedback and stuff. I just wanted something that was extremely lightweight and general. So, you know, for it, like Replete works like in the browser or Dino or Node, and it's like so little code, and it's just simple. And I like things to be simple. Like I'm sort of just really sick. Like when I started making web applications a whole bunch of years ago, there was no tool chain. You just like wrote your JavaScript and imported it as a script. And, you know, that got really unwieldy when we started like building our applications out of modules and they started getting bigger. But you did get fast feedback and it was awesome because there was no like build chain. And now like I've got these projects that use like Webpack, and I hate Webpack so much. I hate configuring Webpack. I hate waiting for Webpack. And I just was like, look, we don't actually need to have really complicated build chains anymore. Like now we've got modules. Now modules are part of JavaScript. We can kind of just leave that stuff in the past. And I'm so glad, I'm so keen to just leave all that heavyweight, clunky, buggy tooling in the past.
Yeah, fair enough. It's cool that you can add things to the context for replete. Are there other ways you'd want to expand on it?
Sorry, add things to what for replete?
I guess add things to the context. So I think that's in response to you're adding a library inline.
I mean, yeah, like you can import modules with it, I guess is the whole point, is that, so for example, like if your application starts off, if the entry point is like main.js, and you've built it, you built the whole application using replete. If you evaluated main.js, that would be running your application because main.js is just a module.
Yep. Yeah, I think they're interested in what kind of feature adds are you interested in trying to build into replete?
Well, I mean, replete at its core, if you ignore the plugins, is a JSON REPL. So instead of a prompt, it sends JSON messages back and forth, and it supports the JavaScript language, and it supports every runtime I could find. So to me, it's complete. I mean, I don't know what else you would add or change. I mean, I love it. I would love it to be better, but like, as far as I can tell, it does everything that I needed it to do. I've just spent the last several months, like cleaning up all the bugs and stuff. And like, yeah, like seems to work for me.
Exactly. Let the community keep going at it now. It's a good opportunity to see where people want to push the boundaries with it. So that sounds great. One question here is, how is the mobile browser integration implemented?
So I'll just, if you're still looking at my screen?
Yes.
Yeah. So this tab here, it points to a web server, which is the sort of replete endpoint for the browser. And I actually host it on 0.0.0.0.0, which means that you can access that tab via the network, like via the local network. So I could go to that in Safari on my mobile. Actually, you know what? I'll just show you. Like, why not? Actually, no, I'm on a different router, so it'll be really complicated. But like, you go to that address in your mobile, and you can have multiple browsers hooked up to Replete. And whenever you evaluate something, it evaluates it in all the browsers using WebSockets.
Yeah, absolutely. Yeah, having that.
Well, I guess it's the same as how you would. I guess it's the same as how you would test a normal application on your mobile. You just go to a local address.
The next question that we've got here is, would you envision a DOM rendering next to the VS Code output too?
I guess you could do that, but I would be more inclined to have a real browser and then have them both next to each other like that. It's really nice when you have two screens, which is how I work with it. I've just got my browser on my left screen with the debugger open, and then I've got my text editor on the right screen. I just send stuff to the browser, so I don't have to alt tab, which is nice. I don't know. I think it would really complicate the plugin to embed a browser like inside the IDE. So no, I wouldn't do that. But you could do that if you wanted, because you can make your own plugin that does that. That's totally fine. Yeah.
Exactly. Pull request welcome. New plugin. That's awesome. That's all the formal questions. Any closing thoughts you want to leave everyone with?
Oh, well, thanks for having me, Brisbane. I'm hoping to move up to Brisbane maybe around the new year. I'm not sure what's going to happen. It's up to my girlfriend where she finds work and stuff. But yeah, it'd be nice to be up there. I'm looking forward to Ashley's talk. He's talking about Pnpm. I use Pnpm. I really like Pnpm. It's a great package manager.
Nice. Good segue too.
Yeah. Check out the Pnpm patch command.
Nice. Well, we get Ashley to explain it all for us. That sounds great. Thank you so much for your talk tonight, and thank you for taking us through a bit of a history, showing us through your particular brand of REPL with Replete, and we're keen to give it all a go. I appreciate your time. Thank you very much.
Thanks, Kevin.
Thank you. All good. All right. So, Ashley, do you still have us with? Do you? Oh my God, I can't English anymore. Do we still have you with us?
Hello. Can you hear me?
Yes, absolutely.
Cool. Hi everyone. Hi Kevin.
Hi. Take it away, my friend.
Yeah, Kevin, just want to say thank you as well for keeping this meetup running as well, despite everything that's going on in the world.
No, it's a pleasure. I absolutely love the community engagement. I think everyone here, especially the Brisbane folks, are highly underrated. We want to make sure that everyone gets the opportunity to chat on the global stage, so to speak. Give everyone that platform. I think is really important. So I'm happy to do it, and I appreciate everyone giving their time and energy to give these talks. So I know when I was attending all of them in the early days, I always got a lot out of them. So I wanted to keep that going.
Cool.
No worries. Take it away, man.
Thanks to James as well for a really fascinating talk. What an awesome first talk for your first time at BrisJS. And the REPL is something I always loved about JavaScript. When I come to JavaScript from languages that I won't mention right now, the REPL was just a breath of fresh air. And I'm pretty excited actually to try out Replete in VS Code. So I'll try and actually do that tomorrow, I think. Okay, so my name is Ashley Davis, and tonight I'm talking about Pnpm. If you've heard of that before, if not, otherwise I'm going to fill you in, so hold tight. Okay, let me get my screen up. Cool. Just before we get into it, I just want to plug my new book, Rapid Full Stack Development. So through this book, I'm trying to help developers build a more effective and more productive development process for themselves. And it's really like what James was just talking about, building like a fast feedback development loop for yourself and learning just how to, not just to write code quickly, but to build code that works really well, works really reliably, and also to make sure that the code's really, really valuable as well. So the early access for my book is now open. So I have written 2 chapters and I've put it on Gumroad for sale for a really massive discount. So it's a chance for people to get on board early for a discount and, make a difference for this book as well. Help give me feedback so I can drive this thing forward. I'm working on chapter 3 now, and that's coming soon. Before we look at Pnpm, where is it? So I've actually written a blog post about this. So I'm actually talking about the content I put together for a blog post. If you want to see all this in a little bit more detail, check out my blog, Code Capers. I've only literally just put it up today. And so there's a bunch of stuff here, like how to create a project from scratch, which I'm going to show you tonight in a live demo. I'm going to show you how to create a Pnpm project from scratch. And then also an example of a JavaScript full stack monorepo, and an example of the same example, but rewritten in TypeScript as well. And a little bit at the end to kind of give you an idea of, how it compares to NPM. So check out that blog post if you want. I've also got all the code for the blog post and the talk online. So if you look up my GitHub repository, Ashley Davis, look under Pnpm workspace examples, you'll find already there basic, which is basically what I'm going to build tonight, a real basic workspace with a couple of dependencies within the monorepo. And then there's a full stack JavaScript example and a full stack TypeScript example there as well for you to play with. And I'll cover, depending on time, I'll cover those quickly as well tonight. So Pnpm, what's it all about? Well, the P in Pnpm, if you can say it right, stands for performant. So it's basically npm, the node package manager, but it's a lot more performant. It runs a lot more quickly. And I reluctantly went to this. So just to be frank, I would prefer to be using npm. I'd prefer to be using the standard thing that comes out of the box. But I just got absolutely fed up with the time it was taking to do npm installs. You know, you want to clone a clean version of a project, you want to duplicate a project to experiment on it or whatever. Like I seem to be doing that every day now, and npm just takes forever. So through work, I got introduced to Pnpm, and it's just so much faster than npm. It's got a much better caching mechanism, and also a mechanism for sharing files between projects, like using symbolic links. And it's just much more effective than npm. I really hope the npm guys learn something and that I can eventually stop using this. It is that fantastic. So it's pretty much a drop-in replacement for npm as well. So most of the things that you'd normally do on a day-to-day basis with npm, you'll just replace pnpm and just use that command instead of npm. And so, you know, there's a few things that are different, but most of the standard things you do every day are basically the same. It's just a lightweight, you know, drop-in replacement for npm. Now, what you're also going to see in my live demo in a moment is that it's got a bunch of useful tools for dealing with workspaces. npm has some of these sort of same style tools, but in my opinion, the ones that are in npm are just kind of clunky and a little bit difficult to use. And Pnpm has tools for managing workspaces that are just easier to use, I think. So this is a great way really to kind of structure a monorepo where you've got multiple JavaScript packages or programs, applications in the same code repository. Let's work through how to build one of these. So I'm just running Windows 11 here, but I think pretty much every command that I'm going to use will work on Mac OS or Linux. I've already got Node.js 16 installed. Now, if you want to install Pnpm, the easiest way to do it is just by npm. So an npm install -g for global Pnpm, that will get it for you. There's various other ways you can install as well if you look at their webpage on different platforms. But if you've already got Node.js npm, you can just install it as a global package, and then you're just using Pnpm. So I just got to make sure I've got nothing in here. So I'm just going to make a project in here. It's just going to be a real simple project just to demonstrate how to get started and how to make a couple of packages within the monorepo depend on each other. So with npm, you do an npm init-y to create a new project. With Pnpm, it's just Pnpm init. You don't need the -y. It just sort of does that by default. And that gives you your package.json. Now, if you're not happy working with the built-in JavaScript date object, which has obviously problems, as we saw in the last talk, you know, you could use something like moment.js, or the cut down kind of equivalent of that is called day.js. That's what I tend to use. And you can install that. So with npm, you use npm install day.js. With Pnpm, you just put a P in front of it, Pnpm install day.js. So we've got that. Now I'm just going to open Visual Studio Code here. And I'll make myself a code file. And I'm just going to cheat a little bit here. I've got a cheat sheet off to the side, so I'm just going to copy some code across so you don't have to worry about watching me type that in. So, you know, There's nothing too exciting here. I'm just running JavaScript code, except I've set up my package file with Pnpm, and I've installed a package using Pnpm. So nothing complicated yet. And you can't see the advantages of this yet because this is such a small project, a small dependency. So, whether you use npm or Pnpm is not going to make a difference for performance until you go to a bigger project with more dependencies or with bigger dependencies. So you're not really going to see the performance aspect of it in this demo, unfortunately. Now, what I want to do here is make this into a monorepo, right? So I want to make a couple of sub packages, and then I want to depend the root package or the root workspace on one of the packages, and I'll make one of the packages depend on one of the others. In fact, I probably won't even take it that far. I'll just keep it real simple, just so you can see the basics. So I'm creating a Pnpm workspace.yaml file here, and I can tell it, where to find sub packages. And let's say I'm going to put them under the packages subdirectory. So anything that I put on, any package that I put under a packages subdirectory will automatically become a package in the workspace, and it'll be symlinked into the other packages that require it. So I'm actually going to create that packages subdirectory here. I'll create a package. I'm just, for lack of imagination, I'm just going to call it A, and actually to line up with my blog post as well. So I'm just going to go down to that directory. I'm just going to init a package file there as well. So this is a sub package. It gets its own package file. I'll create an index.js file down here as well for this package. And just super simple, I'm just going to make it export a function here that says hello world or something. Save that. And I'm going to go back to my root package now, and I'm going to make a dependency on that nested package. So the package is A, and it's coming from the workspace. So what I need to do to kind of connect this up now is just go back to my root workspace and do a Pnpm install. You can just do I if you want the shortcut. So that's actually going to connect it up now. So if I look in my node modules, you can see there's a package A. So that's symlinked. That's a symbolic link to the nested package A. So it's a package dependency within a monorepo. Now, if I go back to my original code file, let's import, bring in package A. So you can see here, I'm requiring in my sub package using just its name. So I'm not using a relative path like what you'd normally probably have to do something like that if you wanted to get this working without these workspaces. And I'll just print that message. So let's just see if that works. Hello from package A. So that's the message that's coming, being imported into the root package from package A. So I could, I don't think I'm going to continue this now, but if you look at the blog post or you look at the code that's on GitHub, you'll see that there's also a package B, and I've just set it up trivially so that package A also depends on package B. Okay, so that's just a real simple example of how you can set up a Pnpm workspace. You can have as many packages as you want and have dependencies between them. Now I'm going to move on. I'm going to show you one of the more advanced examples now, so you can actually see some of the benefits you get for running scripts against nested subpackages. Also, I should show you in the blog post what the structure of this next project looks like. So this is kind of like a fairly typical full stack monorepo here. You can see there's a package.json. You can see that there's the Pnpm workspace file, like what we just created. Pnpm lock here, you can see that's like Pnpm's equivalent of npm's package lock file. Now in this project that I'm about to show you, there's a backend project, so it's a Node.js server. I think it's running on Express. The front end, I think I made it. It's been a while since I actually wrote this code, but I think it's like a parcel bundle, real simple web page, nothing too exciting. And then under a packages subdirectory, we've got an example of a kind of a nested package here, a validation library. So this example, which is like probably one of the best ones that I could think of for a full stack application, is that the back end and the front end both share the same validation code. So you can run validation in the front end for something that's submitted to the back end, and then you can run that same validation in the back end for the ultimate in the secure backend. So I've got the example code open here in another terminal. So this is the Git repo for this project. You can grab it for yourself if you want to try it. The basic example, which is like an extended example of the thing that I just built. And then there's the full stack JavaScript example. And then there's the full stack TypeScript example. Let's go down into the JavaScript example. Now, one of the cool things about Pnpm, and I'm not sure if you get this with npm workspaces because I haven't used npm workspaces that much, but when you get like a monorepo like this, you can just run Pmpm Install, Pmpm I at the top level. That will automatically, you can see there it's scoped across 4 workspace projects, and there's nothing to install here because I've already installed this before. But if you were installing this the first time, it would just go ahead and install all the dependencies for all the nested packages that are in this monorepo. So that's one thing that's really convenient. And you may or may not be able to do that with npm, but I'm not sure off the top of my head. So what do we got here? Let's put some files. So we've got a backend directory. So this is just a Node.js application. It's got a couple of scripts in here like start and start dev to start the backend. We've got the front end here. And in the package file for it, there's start and start dev are the main things here, where you can see where it's running the parcel bundler to put together the static website. Now, one of the useful things that we get with Pnpm, besides the fact that if you look here, you can see that the validation library is included. So there's a validate under the packages directory here. We've got the validation library that's included in both the back end and the front end. So we require that in or import that module in like it came from npm, but it didn't. It came from the same monorepo. But the other thing we can do here is if we look in the package file for the root workspace here, is we can run, we've got some facilities here for running scripts against subrepos. So what we're doing here with the start script at the top level is we're running the start script against all the nested packages recursively. So it's going to run npm start for every sub package, which basically in this case means the backend and the front end. So it allows us to simultaneously start the backend and the front end in this case. The streaming option here is basically so that it doesn't kind of do like output in parallel, which I don't like. It kind of like streams it interleaved. I think it looks a bit better. I think it's and it doesn't collapse output as well. So if you're just wondering where that comes from, so I can run an npm start at the root of my project here, and you can see what it's actually doing here. It's running this recursive start script, and so this is actually starting my back end and my front end simultaneously. So it's pretty convenient that I can one run command here, and it can execute across, or one script executes against nested or multiple nested sub packages. Let's just have a quick look at this. It's just a simplest to-do list that I could do. So I can add to-do items here, and you can see here that if I try and add a to-do item with nothing in it, this is where the validation kicks in. So this is the validation library that's kind of stopping this from happening in the front end. But the same thing also happens in the back end. So where's my VS Code go? Here we go. So if you want to try this as well, like you can actually go into the back end here, load up the HTTP request script. This uses VS Code REST client, and you can run the script here. So here's a HTTP post request to add a to-do item directly to the back end, and it's an empty to-do item. So this should get rejected. So you can see it's a 400 bad request. And the reason that's rejected is because it's using the same validation code in the front end and the back end shared by that validation library. So hopefully you think that's cool. And I just want to scale this up to the TypeScript example now as well. because there's a couple of good examples of scripts in there that you can run. Now, I'm probably not going to show you the code for this one. We'll just move on. But this is the same as the JavaScript version. It's just upgraded to TypeScript. And the key difference here is that our validation library contains types. It contains TypeScript type definitions that we can share between the back end and the front end, which is really cool for having a consistent kind of data schema effectively, going through your REST API for your back end. Actually, I do just have to open this so I can remind myself what are the scripts that I want to show you. So I'm just opening up the package file just to remind myself what the scripts are. Oh yeah, so I can run an npm run compile here. Actually, I'll do a clean first. So doing an npm run clean, that's going to run my clean script against all the nested projects here. This is an example actually of the non-streaming output. So if you remember that stream flag from the last one, this is what it looks like where it kind of groups the output from each package together. Which is okay when the output's only a little bit, but when you get more output, it kind of collapses it and hides output, which I don't like. So normally I would use that stream flag that we saw a moment ago. So I've just run the clean script. That's deleted all the intermediate files and generated files and that kind of stuff. Now I can do a build script. So this is running the TypeScript, the TSC command against every sub package here to compile the TypeScript code to JavaScript code. And the nice thing about Pnpm is because it knows the dependency trees, like it knows that the front end depends on validation, it knows that the back end depends on validation, it will compile them in the right order automatically, which is kind of cool. Okay, so shall we scale up to an even more advanced project? So let me show you where I'm getting this next example from. So this is the open source version 2 of my project DataForge notebook. So I'm open sourcing it this year. So this is a fairly large monorepo. And this program actually, going back to the previous talk, this program is actually, I like to think of it as a REPL on steroids. So it's like Jupyter Notebook, but for JavaScript, and it allows you to kind of run snippets of code and produce graphics like charts and maps and stuff like that. But it's a massive complex monorepo, and you can see under the main directory here, there's a packages subdirectory. So there's a bunch of packages here that are shared in different ways between different parts of this monorepo. There's a plugins directory here. So these are also like sub packages that Pnpm is aware of and can share throughout the monorepo. So there's plugins basically to make the different kinds of visualizations work. And the other thing here I have is a directory called shells, where I like to think of like the complete program. So the browser shell is what makes this thing work in a web browser, and it coordinates all the packages together in a way that works in a browser. And then there's an Electron package here that basically makes this a desktop application. So it coordinates everything together, brings all the packages together in a format that's suitable for running under Electron. And there's a couple of other things here, like the evaluation engine is the server, which basically evaluates the code for this, as I call it, REPL on steroids. And Storybook, which is a really great way, actually, also going back to the previous talk, it's a really great way to kind of showcase individual components, like the demos of components that James was talking about. So there's a shell there for that. And there's also a testbed, which is just my little kind of playground for putting in there and trying out and doing whatever I like and experimenting with whatever I like in there. But you can imagine, managing this thing where each of these is like a separate package, you need something like Pnpm to be able to kind of run commands across all these things. So those same kind of commands that we were just looking at, let me show you how they work here. So I've got similar stuff here, like should have clean. So that's just deleted all the generated code and all the intermediate files for all the projects there. I want to build all the TypeScript code, do an npm run build. Oh no, sorry, npm run compile. So this is compiling all the TypeScript code into the generated JavaScript code, which is actually kind of the end product that you see when you're running this application. I'm not going to worry about letting that complete because it could take a little while after a clean build. But I can also do things like compile watch. And this essentially, if it hopefully it works, it basically does a compilation in parallel for everything. So anywhere that I change code in the project, it's going to go back and just rebuild that effectively. And it works quite nicely with the Webpack setup that I've got for live reload. So I can change anything in any package anywhere. And I've got this running in one terminal, and in another terminal, I've got my Webpack dev server running, and I can change code anywhere, and it'll just show up. I don't know what's going on here. I've got a wall of errors. I wasn't expecting that. Let's just pretend that didn't happen. Yeah, so with Pnpm, you can say recursively run these scripts, but there's also another option. Let me just see if I can pick up an example of that. So that you've got this filter example here. So we're saying basically we want to run here. We want to run the start development server script, but we want to run that against this particular sub package. So it doesn't matter where that package is, like underneath the monorepo. It could be several levels deep. It's just as long as it's got a unique package name, Pnpm is going to find that, and then it's going to run that script against it. So I actually think this works. Again, I don't have a lot of experience with npm workspaces, but I think this is a little bit less clunky than the equivalent kind of thing that you can do normally with npm. So I think that's about all I've got. I did go a little bit over time, but that's okay because I'm the last speaker.
It's definitely all good with me. Thank you very much for that intro. That's a clap as well. That was very much appreciated indeed. And we even had a few questions. Very much in the spirit of like Data Forge Notebook, or being another REPL. I was just thinking about that before. The fact that we can use Pnpm here to just go and completely build that out in one big go is quite amazing, actually. I think I've got a few use cases for that too.
Yeah, this is version 2 for me as well. Like you could, and version 1 was like closed source. I didn't let anyone see that, and it's a huge mess. Like the setup script for that to get everything working right. Like because similar structure, a lot of nested nested code and applications but just before Pnpm and before workspaces, basically a lot messier to deal with. Yeah,
no, look, I kind of wrote that off as being generally impossible or impractical to even achieve without a lot of wrangling beforehand. So yeah, this is definitely seems like a life-saving tool. We had a couple of different questions again in chronological order. One of the earliest questions here was, hi Ashley, do you know if this was a fork of the official npm?
I don't know. I would expect not, because it's pretty different. I mean, the way it structures its data stores and its cache is just remarkably different to npm. And npm, you'll recall a while back, it changed from a nested directory structure to flat. And Pnpm, and I'm not sure if Yarn works this way as well, but Pnpm has just said, no, it's going to be nested. We're just going to do it that way, and we're going to use this completely different kind of, they call it the content addressable store. It's like the data model they use for kind of sharing all the packages you use for everything on your computer, basically, to make it really efficient. And so it's secret sauce. It's very different the way it works to npm under the hood.
Cool. All right. So next question was, after setting up a project with Pnpm, will moving back to npm be impossible once leveraging the multiple nested packages and dependencies, or will it ignore it?
Yeah, it's kind of difficult. It depends on the complexity of the project and how many of the Pnpm features you're relying on. And occasionally I have found a problem with Pnpm and have had to sort of gut it back to npm to figure out how to move forward, basically. In general, Pnpm's pretty good. Like I had a problem with it with Parcel. So what Parcel does, and I use Webpack really for a lot of sort of more professional stuff. But I love Parcel, and Parcel's awesome. But and then automatically Parcel, say you want to use TypeScript with Parcel, it just behind the scenes automatically npm installs TypeScript for you and sets it up. That's one of the great things about Parcel. But with Pnpm, when you're using Pnpm to set up Parcel, it just fails at that automatic install. So then it's a bit more difficult. You've got to know to go back in and install stuff, and it's just an incompatibility, really. The other place I had trouble with Pnpm was where I've had to kind of sort of have both npm and Pnpm working in parallel. Is that when I occasionally kind of deploy like a test or a prototype on DigitalOcean apps, which uses like the what's it called, the Heroku build packs or something under the hood there.
Yeah.
And but it doesn't understand Pnpm, so it's like you can't get it to deploy like a web application on this. Most like all the container-based stuff is fine. Kubernetes is fine on DigitalOcean, but if you're using their new app service that runs that Heroku build packs, like it will fail to install dependencies, and so you have to have to make that work. And I kind of use it rarely. It's just really convenient to be able to deploy something without having to make a build pipeline or something like that. So you just have a package lock for npm, and you have the package lock that Pnpm expects. So you can run them both side by side in limited circumstances. But once you're talking about these big kind of monorepos where there's nested structures that need to be symlinked together, npm can kind of do that as well using npm workspaces. So it might be possible to have them coexisting to some degree as well. I've never done it with that complicated a project.
Yeah, no, it sounds like you definitely need to go and explore it a little bit, because it might require a bit of either translation or conversion of the workspaces just to kind of keep their boundaries in check or something like that.
But, so we're using Pnpm at work as well. So, we've probably, I've used it on about 3 very complicated monorepos so far. And it's just saved so much time and presented hardly any problems at all.
Yeah, no, that sounds great. I guess some of those tooling things that you mentioned, they kind of have expectations or assumptions on the ecosystem. That's, especially when they're trying to sort of inject and dynamically include dependencies and things like that. They're crossing into the boundaries of not being the package manager anymore or being the server at the time. So there's bound to be some edge cases. Hopefully, a bit of contribution to someone like Parcel or something that will make Pnpm happy and vice versa. That sounds pretty great.
I honestly wish Node.js would just take everything that Pnpm's done and just incorporate it into npm, and then we could all just forget about it. We could just go back to using npm, and it would be a joyful experience again.
Yeah, well, look, it's happened in some ways before, when the response to Yarn was quite a significant move by the npm team as well. So you never know, that's how our ecosystem evolves, right? It's a good competition. If people see some great stuff from other folks, then it's good to kind of blow things together. So it sounds good. One of the last questions here is that nested live reload is awesome. Does it patch in the live React live reload correctly too, since that's generally problematic?
I don't understand exactly what that is.
I think questions around, when you got React components, there's a live reload plugin so that it triggers in the web browser as well. So it'll do like a WebSocket poll. I think the question here is that, does the same thing work across updates to the bundler? Would that then republish and get all your Webpack configs to correctly trigger the live reload plugins?
Yes. So I've tried it with Parcel live reload, and it works really well. I've tried it with, I usually use Webpack these days with the hot module reload, whatever it's called, turned off, right? If you in your dev server config, if you say hot equals false, then basically it'll do a whole page refresh, which like for most projects, that's really acceptable for me, because otherwise, configuring HMR in Webpack is such a pain that I almost never can keep it working.
I think that's what this question is alluding to, right? Like they said, it's hard enough for us to get to that point. So yeah,
I rarely use HMR in Webpack, so I don't know how well it plays with that. But I mean, it should be fine. It should be fine. It's just like, at the end of the day, it's just a node module subdirectory with files in it, right?
Yeah.
Same as npm, except in this case, it's symlinked through, and it's almost, in terms of the final thing you get, whether it's npm or pnpm, it's just almost unnoticeable.
Yeah.
And it gives you the same result with a slightly different structured file system, basically.
Yeah, I mean, I used to pull together these different elements via npm link via other installs across the computer. So,
and it's so much easier to do a pnpm link. I didn't say that, but if it because a lot of the stuff that I'm using this with is within a monorepo where it's all kind of automatic depending on your workspace configuration. But you can easily take any other package you've got on your hard drive and just say, pnpm link, relative or absolute path to that module, and it brings it in. Whereas it's a little bit more difficult with npm link because you have to kind of do it on both sides. With pnpm, you only have to do the link on the side where you're linking it in, and it takes care of everything else.
Very cool. Very cool. Last thing is kind of a quick question. Assuming package deduplication is done at the naming level, that's in response to the fact that you said that they needed to be a unique name. I think that's kind of equivalent with all package managers, right? They'll have to be kind of unique.
To be honest, I haven't tried having duplicated names, but it just made sense to me to have all packages have different names. So the name of the package comes from package.json. So you can have things that are in kind of similar named, or at different levels of the tree, maybe the same folder name or something like that. But what really matters is what's in the name in the package.json. And it's really so that when you're running the script with the filter argument from the top level, that you can kind of target that script with a unique name. And I don't know what happens. Actually, I didn't even try it. I don't know what happens if you've got two packages of the same name. Maybe it just runs both of them.
Yeah, I don't think npm would be very happy with it. Your package.json would think it's the same package, right? And maybe a different version or something. So yeah, it might be a bit of a confusion, but it might be relating to different parts of the subdirectories.
I mean, if it doesn't, it should bring up an error really, because you can't then you can't be certain what you're linking to in your dependency tree. So.
Exactly. Yeah. So it should be at least well supported in an error case.
If someone wants to hack my or grab my basic project from GitHub and hack it so that both packages are called package A, and instead of package A and package B, and they can tell us what happens.
I'm assuming explosions will happen. Like that should print kaboom. That should be the expected output, at least in my experience. That's awesome. Well, thank you so very, very much, Ashley. That is all the questions we have for you right now. I will double check the actual live stream chat. Nothing additional here. I'll give it the usual 10-second count as well in case somebody comes back. But I appreciate your time and taking us through all that stuff. That is a super useful tool. It's actually, I hadn't come across it yet either at the moment. So I'm really glad to hear about it. And I'm definitely going to try with a couple of directories that I know could use a bit of better wrangling than what we've set up at the moment. I
think when you need it. If you're, for the nth time that day, you're sitting there waiting for an npm install to complete, instead of going and getting a coffee, hit Control-C and try it with Pnpm install instead.
Yeah,
it's so easy to just replace it with Pnpm. So.
Yeah, and I think a lot of the wrangling was done with like a entirely separate, services running in Docker containers and stuff, and rather than trying to monorepo it instead, thinking that some of these things were impossible. So triggering it, through that is going to be much more convenient for local dev experiences sometimes, in some situations at least. So yeah, I can definitely see some help being applied for this. But yeah, thanks again. And I saw on the chat we had Rodrigo saying, just purchased your book, Ashley. Thanks for your contribution to the community. So thank you very much.
Thank you
Rodrigo.
so
much. Supporting each other is always a good thing. So yeah, that's great to hear. Well, good. I'm going to launch into my bye preamble and thank our audience now. And thanks, Nash. Appreciate it. All good. And that's it, folks. We're at the end. I'm going to share the screen so you know exactly how to reach us if you've got any questions or comments. let me quickly switch back. The old screen share dance. Here we go. That's me. Yeah, so there's a couple of links to how you can get in touch. There's obviously the @BrisJS Twitter, brisjs.org, as I linked before, and there's again, you can sort of check out the Slido. I'm going to put up a poll rating on there in 3, 2, 1. You can give us any feedback that you would like, and you know, I always appreciate everyone's input and how we can make this experience better. And yeah, you can reach out to me personally as well for any kind of organizational needs or any kind of questions on Twitter at KevinDesign and kevinv@brisjs.org. I really appreciate everyone's time and tuning in live. It's been good to have the folks contribute questions and everyone on the chat. It always makes it feel a lot better if you've got some of that interactivity going on. And yeah, thank you very much. I saw the comment coming through. If someone thought it was amazing, I appreciate that a lot. And yeah, we're going to probably close our stream tonight, and we'll see you on the recording. If you've got any ideas brewing of a talk you want to do, even if you've never done a talk before, we'd be really happy to contribute and help you get across the line. It's something that's very worthwhile, and I think as a lot of folks have been presenting BrisJS before, they've seen it snowball. It's become their first talk, and then they did a talk almost, you know, every few months after that, trying to really you know, enjoying the opportunity and the platform that is around. So I do encourage that a lot, and I appreciate that other folks may not get that experience. So BrisJS is here to try and support that. Yeah, thanks everyone. I'm going to drop the slideshow now, and I'm going to say good night to everyone. Have a great time and enjoy your night, and we'll see you next month, hopefully. Watch for the announcements via email and via Twitter and on the Meetup page. Bye all.